Hello and very warm welcome in this lecture on sequences. In this lecture I will explain you the meaning of term sequence. I will cover different types of sequences and I will also explain you the classification of sequences along with different examples. So let's start by seeing what is sequence. A sequence is a set of numbers in specific order that should contain some rule in between them. So let's see different examples. So we have two sequences. One is sequence of even number, another one is a sequence of odd number. So 2, 4, 6 up to 10 is a sequence of even number and 1, 3, 5, 7 is a sequence of odd number. Bear in mind that each element of this sequence is labeled as a term. So we have multiple terms in this sequences. So how we got 4, 6 and up to 10 in this given sequence? We can easily see that if we add 2 in the previous term, we will get the next term which is 4. If we add 2 in the previous term which is 4, we get the next term which is 6. So we can easily see that there exists a pattern, which is by adding 2 in the previous number we are getting the next term of the sequence. Same applies for 1, 3, 5, 7, and like we are getting 3, 5, 7 by adding the 2 in the previous term. So let's see different classification of sequences. A sequence can be a finite or infinite. A finite sequence is said to be a finite if it contains a finite number of terms. Example 2, 4, 6 up to 10, which is a even sequence, and it is example of finite sequence. Why? Because it contains finite number of element or terms. An infinite sequence is said to be infinite sequence if it contains infinite number of terms or continues forever. 1, 3, 5, 7, which is a odd sequence, is an infinite sequence. Why? Because the notation ... implies that it is an infinite sequence and it is going on forever. So let's see how we can label the terms of a sequence. Let us consider we have again that even number sequence 2, 4 up to 10, and we assume that this sequence can be denoted by a term y. Then y1 will be 2, y2 will be 4, which is second term, and y3 will be 6, which will be third term of the sequence. However, in some cases we will also use y0, y1 and y2 and so on. Bear in mind that we use subscript to refer the terms in the sequence. Let's see one example. We have yn is equal to 4n plus 2, and we are given to find y0, y1, y2. So how can we compute y0, y1 and y2? So let's start by finding the y0. So we'll put 0 in the equation, which is n, okay, and multiply it by 4 and add 2, and we get y0 is equal to 2. y1 is equal to 4 into 1, which is n. N is basically given here, like y0, y1, y2, these are values of n. We plug in the values of n in the equation and we are getting y1, y2, y3 and so on. So y2 will be 4 into 2, which is a value for n, multiply by 4 plus 2, and we got 10 in the as a y2. So the best way to understand the sequence is to see the weekday example, which is Monday, Tuesday, Wednesday up to Sunday. Is example of sequence. Indeed, it is example of finite sequence. So since weekdays are the best example to understand sequence. Monday, Tuesday, Wednesday up to Sunday, the example of sequence. Indeed, it is a finite sequence of weekdays. So let us see different types of sequence. We will start by seeing the arithmetic sequence, which is also known as arithmetic progression. It is a particular type of sequence which is formed by calculating the next term by means of adding fixed value known as common difference to the previous value. General notation: a comma a plus d comma a plus 2d comma a plus 3d and so on. Whereas a is the first term in a sequence and d is a common difference between two terms. In case if you want to find the nth term, we will use this formula a plus n minus 1 into d. So let's see some example to understand the concept. So find the term of arithmetic sequence whose first term is 15 and the common difference is 5. So we can see that the first term is 15, which is a, and the common difference is 5, which is d. We will use these values to compute the next term in the sequence, and we will do by putting these values in equation. A is 15, d is 5, and if we compute we will get 20, which is the next term in the sequence. In case if we want to find the third term in the sequence, how will we find that? We'll take a plus 2d, we'll put a, we put d, and we got 25, which is next term in the sequence. So we can use this formula or equation to find the upcoming terms in the equation. So let's see another example, which is write down the terms of arithmetic sequence that has a first term 5 and common difference minus 6. So we can easily see that the first term is 5, which is a, and the common difference minus 6, which is d, and we will take both the values and we will put these values in the equation. 5 plus minus 6 is equal to minus 1, which is the next term in the equation, the sequence. And in case we want to find the third term, we will use a plus 2d. A is 5, d is minus 6, multiply by 2, and if we compute this equation we will get minus 7, which is the third term in equation. So we can do this process again and again to find the next term in the sequence. So let's see if we are given with the problem to find the nth term using the formula. How will we find that? If the first term is 7 and the common difference is 6, find the nth term, which is the sixth term in the sequence. So how will we find the sixth term in the sequence? We can easily see that the first term is 7, which is a, common difference is 2, which is d, and we are given the problem to find the sixth term of the sequence. So we will use this formula a plus n minus 1 into d, and we will put the values of a, we will put the value of d, we will put the value of n, which is 6, and we will compute this equation, and we got 17, which is the sixth term in the sequence. So let's see another type of sequence, which is geometric sequence. A geometric sequence is also known as a geometric progression. It's a particular type of sequence which is formed by calculating the next term by multiplying with the previous term with a fixed value known as common ratio. General notation. So we can represent geometric sequence by a comma ar comma ar square comma ar cube and so on, whereas a is the first term in the sequence and r is the common ratio among the two terms. In case if we want to find the nth term, we will use this equation ar power n minus n. Let's see some example to understand the concept. So example number 1, find the first term of the geometric sequence whose first term is 1 and the common ratio is 5. So using the previous equation, we can easily find the second, third and fourth and up to fifth term of the geometric sequence. So how will we do that? We'll use the equation which is ar square, ar cube and so on. So we'll put the values of a, which is 1 in this case, and r, which is a common ratio, is 5, and we got 5, which is second term in the sequence. To find the third term in a sequence, we will use ar square. We'll put the values of a, which is 1, we will put the value of common ratio, which is 5, which we will take the square and multiply it by 1, and we got 25, and we will continue this process until we'll get the fourth terms of the geometric sequence. So let's see another example where we are given with the problem that we have first term is 3 and common ratio is 1/2, and we need to find at least few of the geometric sequence terms. Okay, let's see how we can do that. So we'll use same formula, AR comma AR square comma AR cube, to find the next coming term in the sequence. We'll plug in the values of A, which is 3 in this case, R, which is common, which is 1 by 2, and we multiply it by 3 and we got 3 by 2. And in case we want to find the third value in the sequence, we'll use this formula, AR square. We'll plug in the values of A, R, and we got like 3 by 4 and comma 3 by 12 and so on. So in this way we can easily find the values of geometric sequence. So let's see another example where we need to find the nth term using the formula. If the first term is 7 and the common ratio is 2, we need to find the sixth term of the geometric sequence. So how will we do that? So we use the formula which we have covered in the previous slides, which is AR power n minus 1. In this case, A, which is the first term, is 7. Okay, common ratio is 2. Okay, and we need to find the sixth term in the geometric sequence, and we'll put the value of n here, and we'll compute this equation, and we got 2 to 4. So 2 to 4 is the sixth term in the sequence. So let's see the last type of sequence, which is infinite sequence. A sequence is said to be infinite if they go on continuously indefinitely. Like we have seen many examples of these sequence in the previous slides, like 1 5 25 125 625 and so on. So the notation dot 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 implies that it's an infinite sequence and is going forever. Let's see another example, which is 1 1 by 2 1 by 4 1 by 5 and so on, and it approaches to 0 as keep on increasing the denominator. We can see that as 1 by n gets bigger and bigger, the overall term becomes nearer to 0. We can easily see if we increase the n, okay, and if n approaches to infinity, definitely the overall term will become 0. So we can easily rewrite this equation in this form, where the limit approaches n approaches to infinity, and 1 by n will approach to 0. Lastly guys, I want to make an announcement that in near future I am making more videos on discrete math, computational math and cyber security. Especially I am focusing more on malware analysis. If you are interested in learning more about these domains, just subscribe my channel, hit the bell icon, and I hope to see you soon in the coming videos. Bye.